So very good morning. Mudassir sir, your roll number? Please mute your mic.
आज लग जाएगा है बस
Mudassir, mute your
लग
mic.
जाएगा हेलो
Mute your mic and say your roll number.
शेख मुजाहिद रोल नंबर C7
Mute your mic, Sheikh Mujahid. So in previous lecture number 7, we started the unit number 2. That is the simple lifting machine, and in that we have seen the course outcome and learning outcome and unit outcomes of the unit number 2, and the relevance of this unit with the real life problem you can see here, and utility with respect to real life you have seen, and also for lifting heavy load we are using machines, simple lifting machine and sometimes compound lifting machine. Students, I request you to join with your own name and write your roll number before your name. Don't join with
C10 सर C10 मोहम्मद अनस
okay, mute yourself. Lifting machine helps to understand the concept and source type of loads and natures, machine parts, behavior of machine, member under load, and the prerequisite concept of the, also we have seen then definition of machine and lifting machine, simple screw jack and the pull, simple wheel and axle machine attachment as a pulley block, and types of machine, simple machine and the compound machine we are also seen. Also we have seen the effort versus the load, and a different simple lifting machine, inclined plane, compound lifting machine, and their examples, that is the crane and inclined plane with the pulley block. If two machines are used for lifting is then that is called as compound lifting machine, and then we have seen the difference between the simple and compound lifting machines. Also we have seen the mechanical advantages and some examples of the simple lifting machines we have seen in the study class. Also the basic concept and definition of load, effort, mechanical advantage yesterday we have finished, and we started the velocity ratio. So what is the velocity ratio? It is a ratio of displacement of the effort to the displacement of the load. It is a ratio of distance traveled by the effort or the distance traveled by the load. So that is simply we can say that the velocity ratio is y upon x. Velocity ratio is always more than 1, and for a given machine it remains constant. It also no unit being the ratio of quantity of same units. So velocity ratio is the unitless quantity because the denominator and numerator, their units are the same. Uh, that's why there is that is unitless quantity. Now in today's lecture again we will see in detail the velocity ratio and efficiency, types of machine, real machine, law of machines, maximum mechanical advantages, reversible and non-reversible machine and condition for reversibility, etc. We'll see in today's lecture. First, upon before going for the efficiency, so you understand the velocity ratio is nothing but the ratio of simply distance traveled by the effort, that is y. It is the distance traveled by the effort, it is related with the effort, and distance traveled by the load, that is related with the load, and that is denoted by x. The ratio of distance traveled by the effort to the distance traveled by load is termed as velocity ratio. And the value of velocity ratio is always 1. It is characteristic, and it is constant for the machine, same machine. Okay, so he joined now, Saif Ali Khan. Then you will see, before going for the efficiency, we'll see that the input of the machine. What is the input of machine? It is multiplication product of effort applied and the distance traveled by the effort. So yesterday also we have seen very good this example. This is the effort we are applying downward. This one is the effort we are applying downward, and due to the effort applied, the distance traveled by effort is nothing but your input of your machine, and it is denoted by the load we are, or pressure we are, or load applied on uh, the lever to come down, and that is called as effort. So distance traveled by the effort is called as y, and that load needed for that effort is the p. So that's why input is nothing but, what is the input? Input is nothing but p into y. So you can see here the amount of work done by the machine is nothing but input of the machine. So it is the effort into distance traveled by the effort. Its unit is kilonewton meter, because uh, effort in newton or kilonewton, and distance traveled it may be mm or in meter. That's why the unit of the input of the machine is nothing but newton mm or kilonewton meter, you can say. Similarly, you can say that the output of the machine. So if we see here, the output of the machine will be the distance traveled by the load to the load. है ना? The load is denoted generally by W, and distance traveled by load is the X. So the W into X is the work done, and it is called as the output of your machine. It is called as the output of your machine. So here you can see the output of the machine. It is also denoted by the kilonewton meter or newton mm, because the load will be in the or the weight of that material will be in newton or kilonewton. That's why we can say that the distance traveled by the load, and the load is nothing but the work done by the load, and that is nothing but it is the output of your machine, and it is generally load W into or distance traveled by the load is the X. So W into X is the output of the machine. Now what is the efficiency of the machine? You know that efficiency is nothing but the ratio of output of the machine to the input of the machine in percentage. तो अभी यहाँ पर आपको समझ में आ गया कि इनपुट ऑफ द मशीन क्या है. इनपुट यानी जो एफर्ट से हमारा वर्क हो रहा है, वर्क डन हो रहा है, उसको क्या बोलेंगे, इनपुट ऑफ द मशीन. तो वर्क क्या हो रहा है, लोड जो हम लोग अप्लाई कर रहे हैं और जो डिस्टेंस ट्रैवर्ड हो रहा है, दैट इज द वाई. तो इट इज़ अ प्रोडक्ट, input of the machine, it is a product of effort into the distance traveled by the effort. So that is input of the machine. Similarly out of the machine क्या है, आउटपुट ऑफ द मशीन ये है कि लोड जो हम लोगों ने उठाए एफर्ट से, तो वो कितना उठा और वो कितना डिस्टेंस ट्रैवल्ड किया. इट इज़ डिस्टेंस ट्रैवल्ड इज डिनोटेड बाय एक्स and load is W. So W into X, that is work done, and that is said to be the output of the machine. तो ये है आउटपुट ऑफ द मशीन, और ये एफर्ट जो है ये क्या है, हमारा इनपुट ऑफ द मशीन है. ये लोड उठाने के लिए हमने जो एफर्ट लगाया वो इनपुट है, और जो लोड उठा दैट इज द आउटपुट. ओके. तो सिमिलरली everywhere when we are providing some input, then you are getting some output. Okay. So here the output of the machine is W into X, and input of the machine is P into Y. Now then what is the efficiency? So if you will see here, the efficiency of machine, it is a ratio of output of the machine to the input of the machine. Output of the machine क्या था हमारा? If you will say that output of machine is nothing but we have written W into X, and input of machine हमारा क्या है? It is P into Y, distance traveled by the effort, and the effort in Newton. And generally efficiency is denoted by in percentage, so that we are writing here 100, multiplying with the 100, so that we will get the efficiency in the percentage. So that efficiency is nothing but the percentage efficiency. Okay. So percentage efficiency is denoted by neta. Neta in percentage is equal to W into X divided by P into Y into 100. Further we can write that W upon P, है ना, W upon P, and this X will come down, so we'll write Y upon X. This P will come up, it will denoted by W upon P. Okay. And here X will come down, and then we will write it as a Y upon X. So you can write like this also, W upon P. Okay. And it is upon Y upon X. X will come at the lower side down. Okay. So you know that what is W upon P? W upon P is our mechanical advantage. W upon P is upon mechanical advantage, and Y upon X is what? Y upon X, it is a velocity ratio. So efficiency of machine क्या हो गया? It is a ratio of mechanical advantage to the velocity ratio, है ना. Mustafa, you are too late, huh? This should not be happen in next class. So here you can see when we come to conclusion that the efficiency of a machine in percentage, it is nothing but the ratio of mechanical advantage to the velocity ratio into 100, because we are generating efficiency in calculating in percentage. So this is the formula to know the to calculate the efficiency. तो आई थिंक सो आपको समझ में आ गया होगा कि what is the input, what is the output, and what is the efficiency of machine. The ratio of output to the machine to the input of machine in percentage is called as efficiency. When we put the all the values, then we come into the conclusion that efficiency is the ratio of mechanical advantage to the velocity ratio into 100. So this eta is the Greek word generally denoted the efficiency. So all details are as we are discussed here, and that should be useful for making a notes. Now will come that different types of machine that can be uh, classified based on the eta value. So in general, when we say the machine are divided into two types, uh, the types of machines you can say. The first one is the real machine, and the efficiency of real machine is always less than 100%. So efficiency of real machine, you can say it is always less than 100%, and here also friction we can count it. So definitely the friction will become into the picture and the opposing pole, so that the efficiency is reduced. And there are losses, and that losses we can, maybe the friction loss, maybe another loss, that is nothing but called as the mostly it is called as the friction loss, and the friction loss is nothing but the too late Samir Malik and Tarhan Sari. You are daily regularly joining late, and this is your loss, this is not our loss. So please try to join on time. You are disturbing the class. We can see here the types of machine. अगर हम देखेंगे तो रियल मशीन या फिर एक्चुअल मशीन किसको बोलेंगे, जिसमें फ्रिक्शन हो, लेकिन फ्रिक्शन लेस तो कुछ भी नहीं है, और कोई भी मशीन 100% इफिशियंसी नहीं देती है इन रियल लाइफ, है ना। तो एक्चुअल मशीन और रियल मशीन किसको बोलेंगे, जिसकी इफिशियंसी लेस देन 100% हो। हाँ, जिसकी इफिशियंसी अगर इक्वल टू 100% हो तो मशीन को हम क्या बोलेंगे, इट इज़ आइडियल मशीन। So what is the definition of ideal machine? If the machine is having the efficiency equal to 100% and there is no friction between the surfaces, then only we'll get the 100% efficiency, and that is called as ideal machine. That is called as ideal machine. And there is in nature nothing exact such ideal machine. There is always some opposing force, and that is the efficiency is less than 100%. Now based on the value of efficiency, that is eta value, based on the value of eta, the real machine or actual machines are divided further into the reversible machine. The reversible machine means when the efficiency is greater than 50%, then the machine is said to be reversible machine. अगर मशीन का efficiency आपके greater than 50% है तो उसको क्या बोलेंगे हम लोग, कौन सी मशीन बोलेंगे, उसको हम बोलेंगे रिवर्सिबल मशीन। इसी तरह अगर आपका एफिशिएंसी लेस देन 50% है and that machine is said to be irreversible machine. So based on the efficiency, the machine types of machines are classified: reversible, irreversible, and machine at a point of reversing. If the eta value is equal to 50, so we can say that the machine is at the point of reversing, and these three types of machines we can study here. ओके, तो मेरे ख्याल से अभी तक जो मैंने समझाया, मैकेनिकल एडवांटेज, इट इज़ द रेशो ऑफ effort upon the load apply, load upon the effort applied. It is the mechanical advantage, and the velocity ratio is the effort distance traveled by the effort to the distance traveled by the to the load, and efficiency is the ratio of mechanical advantage to the velocity ratio in percentage, or you can also say that output of the machine to the input of the machine is the efficiency of your machine. So always the efficiency is less than 100% because of friction losses, and based on that is that different types of machine are there. Now we'll see the reversible machine. When a machine is capable to doing some work in the reverse direction even on removal of effort, is called a reversible machine. When machine is capable of doing some work in reverse direction even on removal of effort, it is called as रिवर्सिबल मशीन। तो ऐसी मशीन जो इफर्ट निकालने के बाद भी वो वर्क करते रहती है अपोजिट डायरेक्शन में, उल्टा घूमती है, तो उसको क्या बोलेंगे हम लोग? रिवर्सिबल मशीन बोलेंगे। कंडीशन ऑफ रिवर्सिबिलिटी क्या है? द वैल्यू ऑफ नीटा शुड बी ग्रेटर देन 50%। हम लोगों ने देखा यहाँ पर द वैल्यू ऑफ नीटा इज द ग्रेटर देन 50%, देन ओनली वी कैन से द मशीन इज रिवर्सिबल। तो दिस इज द कंडीशन ऑफ रिवर्सिबिलिटी। जब इफिशियंसी आपका मोर देन 50% रहेगा, देन ओनली वी कैन से द मशीन इज रिवर्सिबल मशीन। Otherwise, you can not say that the machine is the reversible machine। यानी जो डायरेक्शन में वर्क कर रही है उसके अपोजिट वर्क करेगी। कब करेगी? जब इफिशियंसी आपका ग्रेटर देन 50% रहेगा। उसको हम लोग क्या बोलते हैं? कंडीशन ऑफ रिवर्सिबिलिटी। तो एग्जाम में ये पूछता है रिवर्सिबल मशीन क्या है, कंडीशन ऑफ रिवर्सिबिलिटी क्या है, तो यू कैन एबल टू एक्सप्लेन दिस, ओके, based on the eta value. Similarly, non-reversible machine or locking machine, when machine is not capable of doing some work in reverse direction even on removal of effort, is called as irreversible machine. So what is the condition of non-reversibility? The condition of non-reversibility is the value of eta or efficiency should be less than 50%. Then only we can say that the machine is non-reversible, irreversible. You can say the type 2 here, and type 1 reversible, and type 3 machine is at the point of reversing when the efficiency is exactly equal to 50%। तो मेरे ख्याल से you understand this now, the types of machine, based on the efficiency and their conditions of reversibility and irreversibility are explained. So this non-reversible machine is also called as locking machine, and actual machine हम लोग ने देखा the machine uh, the efficiency is always less than eta is less than always 100%, then it is called as the actual machine or real machine, and their mechanical advantage is always less than the velocity ratio, always less than the velocity ratio. Now what is the ideal machine? The machine which efficiency is equal to 100%. So if the eta value, that is efficiency of the machine, if it is 100%, then we will say that that is the ideal machine. And in this case machine is completely frictionless. तो ऐसा तो I think so it is not happen in nature, in the real world. And velocity ratio is equal to mechanical advantage. These all are the characteristics of the ideal machine. You can remember and it can be useful for the examination. So you can say that the characteristic of ideal machine is efficiency of machine is 100%, machine is completely frictionless, and velocity ratio is equal to mechanical advantage. Or you can say that input is equal to output. So that is nothing but your ideal machine. Okay, so this is the definition of your ideal machine and real machine. Now we'll see the law of machine for ideal machine. So an equation which represents the relationship between load lifted and effort applied is called as law of machine. So here you can see that in the graph the value of C is the constant, because to start the machine we need a certain effort है to overcome the initial friction, and that value is C. So what is the law of machine? The P is equal to, you can say P is equal to mw plus C. Why plus C? Because to start any machine we need certain effort, and at the start that effort is C. P is the effort applied to lift the load, W is the load lifted by the machine, and U is the slope of your straight line, and that is generally uh, value we can slope, you can find out the tan theta. So M here is the slope, W is the load, P is the effort, and C is the effort at the start to require or to run the machine, and it is called as the law of machine. So you can simply uh, by represent by the graphical method also. So you can see here is 2 point, and when you are lifting the load, so you can get on axis 2 point, the graph of load W versus effort. So x1 y1 you can say, and x2 y2, these are the coordinate of load and the efforts. Okay, so this is the law of machine. ये लॉ ऑफ मशीन है कि हम कोई भी सामान एक जगह से दूसरी जगह उठाते हैं, तो दैट इज़ द एफर्ट, एंड द थीटा वैल्यू, tan theta value, that is nothing but m, and m is the slope of the your straight line. So it is, you know that the effort applied and load, if you plot, it is always in a straight line. हाँ, अगर आप इसी चीज़ को, अगर दिस लॉ ऑफ मशीन को अगर आइडियल मशीन में अगर आप करेंगे, तो P इज इक्वल टू mw, हाँ, because in ideal machine this line will start from the origin, and we don't need effort to start the machine because the, the surface is frictionless. So therefore, for ideal machine, we don't need an effort. So that's why you can say that initial effects are not required. That's why the value of P is equal to M into W for ideal machine. So this equation can be reduced to the this law of machine for ideal condition. If you say, then this will be the P is equal to M into W. Their C value will be 0 because the friction is 0 in the initial friction when there is ideal machine. Now this equation which gives the relationship between load lifted and effort applied in the form of slope and intercept, that is the x1 y1 x2 y2 of a straight line, is called as law of machine. That is P is equal to mw plus c is the equation of a straight line. You know it, where P is the effort applied and W is the load lifted, and M is the slope of line, and C is the y-intercept, that is initial effort required to start. For getting this relation, effort is applied on a machine and corresponding values of load are noted down. Then the graph of load against effort is plotted by taking load W on x-axis and effort on y-axis, that is P, shown in the figure. It is been observed that the graph of W is proportional to the P. If it is proportional to the P, then it is called as it is a straight line. Cuts the y-axis, giving the intercept C, which indicates that effort lost in the friction when load is lifted. So there is always some friction, and that's why this uh, value C, the constant C, is there always in real condition. But in case of ideal condition, then this value will be 0. So this can be related. We have seen the above figure also. This figure is also for that. And how to find out the slope, that is M. So M is equal to slope, and it is denoted by the tan theta. So tan theta, you know that it is nothing but opposite upon adjacent. तो यहाँ पर अपोजिट क्या है, अगर हम यहाँ देखेंगे तो this one distance from this one to this one, so that this is nothing but y2 minus y1 to the adjacent, yani this distance, you can say that distance will be x2 minus x1. So from that you can easily slope of graph, you can easily find out for the equation, and the other value you can easily find. One more, it is too late. Uh, Please try to join
Sorry, sir. Your
in
mobile.
small time. So this is nothing but you can say that the effort and the load, and the equation is called as law of machine. This equation is called as P is equal to mw plus C is the law of machine, and C is the initial effort, and this axis Y is effort, axis X is for the load, and there is 2 point initial position of the your load, and this is the final position of the load. It is denoted by x1 y1 initial position, and final position is denoted by x2 y2, and this is the distance. You can P is equal to mw plus C is the distance traveled, and this theta, tan theta, is nothing but that is M is equal to the tan theta, and tan theta is equal to opposite upon adjacent, that is y2 minus y1 divided by x2 minus x1. Then we can find out the value of theta by inversing the value with the tan. We'll get the theta value. Then what is the ideal effort? व्हाट इज़ द आइडियल इफर्ट। अभी तक हम लोग ने जो पढ़ा आपको समझ में आ गया होगा। हम समझते हैं कि आइडियल इफर्ट क्या है। The effort which is required to lift the load when there is no friction is called as ideal effort. अगर कोई भी लोड को हमको उठाने के लिए जो इफर्ट लगता है और वहाँ पर कोई भी फ्रिक्शन नहीं है, तो ऐसे इफर्ट को हम क्या बोलेंगे? ऐसे इफर्ट को हम बोलेंगे आइडियल इफर्ट। क्या बोलेंगे ऐसे इफर्ट को? आइडियल इफर्ट। तो आइडियल इफर्ट अगर हम बोलें तो इट इज़ W upon VR. It is the ratio of W upon VR. That is nothing but W is the load to be lifted and VR the velocity ratio and PI is the ideal effort. PI is the ideal effort. Similarly, if you define the ideal load is the load which can be lifted by effort P when there is no friction is called as ideal load. If there is no friction, then that is called as ideal load. So that's why Wi is equal to P into VR. Wi is equal to P into VR when the load lifted by effort P when there is no friction, so then that load is called as Wi. Okay? तो यहाँ तक सबको समझ में आ गया? कोई और डाउट है तो यू कैन आस्क नाउ एंड अदरवाइज वी विल प्रोसीड। तो आई थिंक सो सबको समझ में आ गया, इसलिए कोई आंसर नहीं आ रहे थे। ओके, तो विल प्रोसीड। ओके, इफ यू आर नॉट any doubt, then we will proceed. So you can see here the ideal load and ideal effort, you understand. When there is no friction, that effort is called as ideal friction, and when the load is lifted and in ideal lifted condition, ideal effort condition, then there is that load is called as any no friction condition, that load is called as the ideal load. So this is the definition of ideal effort and ideal load, and the formula for the PI is equal to W upon VR, and WI is equal to P into VR. So these formulas you should write down on the one page, and that will be useful for your tutorial class. I will announce for your tutorial class in coming classes. Inshallah, we will put your tutorial class so that you can easily calculate your examples for your examinations. Now, what is the lever arm? A rigid bar which is provided in a machine so as to apply the effort is called as lever arm और हैंडल। तो जैसे कि हम लोग ने ऊपर भी बहुत सी फिगर में देखा कि लीवर आर्म क्या है। जनरली दिस फिगर विद द वेज in simple lifting machine, you can see the effort and displacement we have seen. So this 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 bars is called as nothing but lever arm. So initial position in this direction, and when we lift the forward, the position is changed to the lever arm, and that is called as lever arm. So you can understand what is the lever arm. The bar we are using to lift the load easily by the help of lever arm. So it is a rigid bar, and that is acting as a when we jointly use with the wedge, it is a simple machine. So rigid bar which is provided in machine so as to apply the effort is called as the lever arm or handle. तो ये आपको समझ में आ गया है ना। तो लीवर आर्म क्या है कि जो ऐसा रिजिड बार जो कि हमको मशीन में हम प्रोवाइड करते हैं टू टू अप्लाई द एफर्ट और टू लिफ्ट द लोड, है ना. Now we can see the maximum mechanical advantage. So when will be the maximum mechanical advantage? The mechanical advantage is W upon P, है ना. And P is in the law of machine. You have seen that P is nothing but M W plus C, है ना. This equation in law of machine we have seen. So we will put this. So what happened, dividing the numerator and denominator by W, अगर W से हम divide करते हैं तो we'll get this mechanical advantage is equal to 1 upon M plus C upon W. C is the constant and W is the load. M is nothing but the slope line, C is the white intercept. In above equation, if W is more, then ratio C will be very small. Therefore, neglect the ratio CW. So, if we neglect the ratio CW, if we avoid this ratio, what it will happen? It will be 0. If we neglect means the C by W ratio will be 0. So, what happened? The mechanical advantage is equal to 1 upon F, 1 upon M. So, if the mechanical advantage is 1 upon M, then that is called as uh, the maximum mechanical advantage. तो हम ऐसा भी बोल सकते हैं कि मैक्सिमम मैकेनिकल एडवांटेज मीन्स इट इज द रिवर्स ऑफ योर स्लोप. It is the reverse of 1 upon m means inverse of the slope. So it is inversely proportional to the slope. That is the maximum mechanical advantage. So this you can see that the maximum mechanical advantage is equal to 1 upon m, and at this condition you will get the maximum efficiency. The maximum efficiency is the ratio of maximum mechanical advantage to the velocity ratio, the 1 upon m into VR. This is the formula for the maximum efficiency, and this is formula for maximum mechanical advantage 1 upon m. So we'll stop here. I think so you understand better, and no need of explain. If still you have any doubt, you can ask, because within the 5 minutes you have another lecture, and then effort lost in friction and other things we will see in next class. So thank you for joining today, and I hope you will join regular like this and for the lecture. तो आज जो हम लोग ने पढ़ा हमारे ये लेक्चर नंबर 8 में, इट इज़ सबसे पहले तो वेलोसिटी रेशो, और उसके बाद इनपुट ऑफ द मशीन, output of the machine. Then we have seen the types of machine, and we have seen the ideal machine, real machine. We have seen law of the machine. Then we have seen maximum mechanical advantage, maximum efficiency, and reversible and non-reversible machine. And also we have seen the conditions of reversibility and condition of non-reversibility based on the efficiency. Okay, so we will stop here. If you have any doubt, then you can ask any question regarding today's lecture. You can ask, otherwise I will take the attendance.